All right, 4.3 covers rotations. So our essential question is, how can you rotate a figure in a coordinate plane? I haven't given you a whole lot of room here for repetition, so maybe you can do it on a separate sheet of paper, or you can, write your questions here. And there's a little bit of room down here for a very small summary. You should also have a piece of tracing paper. Okay, so I'm going to give you a couple of definitions up here at the top. First of all, we'll talk about the center of rotation. So figures are rotated about a center. So it's a fixed point that a figure is turned about. So an example of like a center of rotation, we've been using our compasses quite a bit. So maybe I can just show you real quick. So if I had my compass, that center of rotation would be my point here. And then let's say I had some point where my pencil is. And if I just rotated that around, that's actually like 180-degree rotation. And I'm rotating it around, or about this compass point right here, the center of rotation. So just an example. We'll do plenty more today. So an angle of rotation. All right, well, an angle of rotation, now the Greeks are the ones that came up with geometry. So we tend to use the Greek alphabet a lot in geometry. This right here is theta. This is a Greek letter, theta. And we tend to use that a lot for angle measures. So think of that as like x. Instead of x, we're using theta. It's just another letter, but it's in a different alphabet. So this is the measure of degrees that a figure is rotated. So for example, for this one, this little example I did, I forget where the center was, maybe it was here, right? And so this, going from this point up here down to this point here, the angle of rotation is 180 degrees, right? Starting here, ending down here. Okay, now unless otherwise specified, a rotation about a point always turns an object in a counterclockwise direction. So if you go clockwise, that's actually going to be a negative degrees. And we'll talk about that in a little bit. Okay, so let's highlight a couple things here. So we've got a center of rotation. Now for us, we're just going to use the origin. So in any coordinate plane, we'll just use the origin as our center of rotation. Angle of rotation being a Greek letter, theta. You can also use x or any other variable you want, any other letter out there. Okay, and then this is important. Unless otherwise specified, a rotation about a point always turns an object counterclockwise. That's very important. Okay. So we're going to explore these rotations using our tracing paper. We'll come up with some rules, and then I expect you to know the rules. You won't get to use tracing paper on your tests. All right, so let's do some of these and come up with some rules similar to what we did with reflections. So on each graph below, plot the following points, C, A, and T. Perform the given rotation and write a rule in rotation notation. Or basically, just like our general rule, that's what we're going to write. Okay, so the first one is a rotation of 90 degrees about the origin. Okay, and like I said, they're all going to be the point of rotation, or the center of rotation is always going to be the origin for us. Okay. So C is -3, 1. A is -2, 2. And T is 0, 1. And I'll use a couple of different colors here. So let's see. How about we'll do green and purple. Just to differentiate. So there's CAT. Triangle CAT. Okay. So what I'm going to do is I'm going to use my tracing paper. I'm going to go ahead and put CAT on here. Now the other thing is, what's a little bit tricky, I guess, is to understand how far we're rotating. So I'm going to, because we're rotating about the origin, I'm going to make a little mark here at the origin. This will be my x-axis, this will be my y-axis. And when I rotate a certain amount of degrees, it's important that I basically think about where the x-axis should be and where the y-axis should be. And the origin should line up with the origin. So let's think about angles, okay, and how many degrees each angle is. So if I were to go, for example, from the x-axis, the positive x-axis, to the positive y-axis, that's going to be a positive 90 degrees, right? That's a right angle right there, and I go from being horizontal to being vertical, so that's 90 degrees. And then if I go from the y-axis to the negative x-axis here, that's another 90 degrees. So from the positive x-axis to the negative x-axis would be 180 degrees. Okay, so that's, we're going to use that to help us kind of think about how we rotate this, right? So 90 degrees about the origin. My origin is going to stay at the origin, but my x-axis is now going to become my y-axis, right? So that's a 90-degree rotation, and I'm going counterclockwise, so I can get a positive 90 degrees. So it looks like C now is at -1, -3. That's C prime. I'm just copying these down. A is at -2, -2. I should say A prime. And then T is now at -1, 0, or T prime. Okay, so I'm going to put that as a different color. Yikes. Okay. So let's come up with a general rule for this. So again, C, I'm going to write down the original points. Okay, and then C prime became -1, -3. A prime became -2, -2. And T prime became -1, 0. So let's think about what happened here. First of all, you should be recognizing that the x's and the y's, what did they do? They tended to switch, right? So the x's and the y's switched. So we know that for any point that we originally had, that new point now had the y first and then the x. Well, and what else happened? So if I look at all of the y's, right, they're now the new x's. Well, they're not exactly the same as the old y's, right? These all were positives, and these are all the opposite of those. So we did the opposite of y, made that into our x, and then x became our y. So that's the general rule that we're going to use for any rotation that is 90 degrees about the origin. Now 90 degrees about the origin, right, so we just went, let me take this back here. we just took the x-axis, positive x-axis, put it on the positive y-axis. That was 90 degrees. Now what if I went all the way around? So then the positive x-axis becomes the negative x-axis, the positive x-axis becomes the negative y-axis, and now I'm all the way back. Well, that's a total of 360 degrees, right? Think of it as like a circle. So what if I went clockwise, right? So if I went, let's see, that would be 90 degrees, where the positive x-axis becomes the negative y-axis. That would be 180 degrees clockwise, right? And one more would put us back to where we were. So that's going to be 270 degrees clockwise, or that's a negative 270 degrees. Okay, so let's write that down. This is also or negative 270 degrees. Okay, so that's important to know. All right, let's go ahead and do it again for a rotation of 180 degrees, and let's see if we can come up with that general rule. Okay, so a rotation of 180 degrees about the origin. Let's see, we're going to start with CAT. So that's negative 3, 1. Oops, what have I done? Actually, I think this time I'll go ahead and write out those coordinates. And this way I won't have to actually lift my paper, I don't think. Let's see if I can get that. All right, so I'm going to start with CAT. The way that it's set up, origin on top of the origin, x-axis on top of the x-axis, y-axis on top of the y. Okay, now I'm going to go 180 degrees. Okay, so counterclockwise. 90 degrees, just put the positive x-axis on top of the positive y. 180 degrees now puts the positive x-axis on top of the negative x-axis. All right, so let's see. So t became 0, negative 1. A became 2, negative 2. And C became 3, negative 1. Okay, so I'm going to go ahead and draw that now. So C prime, oops, I forgot to put the C prime. There we go. Sorry about that. I got excited about writing them down. Alright, so C prime becomes 3, negative 1. A prime became 2, negative 2. And T prime became 0, negative 1. And now let's see if we can come up with a general rule. So it looks like all the x's, well, at least the absolute values are there. And then all the y's, those numbers match too, except for what's different in both the x's and the y's. So for every point, x, y, what happened? Well, it looks like they stayed the same, right? X and y stayed in their same places. But all these negatives became positives, and all these positives became negatives. So it looks like we did the opposite of both of them. So there's your general rule. And this should look very familiar to you. Let's see here. Where we took our point and all we did was take the opposite of the x and the y values, that's exactly the same as what we did as reflecting in the origin, right? Your general rule was you take the point and you just do the opposite of the x and the y values. So this is actually a rotation 180 degrees about the origin is exactly the same rule as the reflection in the origin. Okay, now, rotation of 180 degrees about the origin. That was counterclockwise. So what would it be if we went clockwise? So let's line it back up. And let's try and get this triangle over on top of this triangle going clockwise and see how many degrees I go. So putting the positive x-axis on the negative y-axis, that's 90 degrees clockwise. And then one more rotation here of 90 degrees puts the cat triangle right on top of itself, right? Okay, so that was basically, I did 290 degrees or 180 degrees clockwise. So that's going to be a negative 180 degrees. Like halfway around the coordinate plane. All right, and then we got one more to do, a rotation of 270 degrees about the origin. So I'll do the exact same thing. Let's see, I'm going to write the coordinates. And this time I'll say C prime, A prime, T prime. That way I don't get excited and just write down the coordinates. All right, so negative 3, 1. So there's our original triangle. And now I'm going to rotate it 270 degrees. So that means, if this was 90 degrees, 180, I need to go one more time, okay? One more than we've done so far. Okay, so 90 degrees is one of these rotations. Okay, that was like our first one. 180, we get one more rotation here. That's like our second one. 270, we need 90 degrees more. So it looks like C will be 1, 3, or C prime I should say. A prime will be 2, 2. And T prime is going to be 1, 0. So what's our rule? General rule for every single point. Let's see, first of all, what used to be my x's now become my y's. And what used to be my y's now become my x's. Except the signs aren't exactly the same. So which one's being changed this time? Okay, so we switched y's and x's. And this time our x's are opposite, right? So notice this was negative 3, negative 2, and when we switched them, now it's positive 3, positive 2. So it's the opposite here. Okay, so that's your general rule for any rotation of 270 degrees. Now the question is, if we rotate this clockwise, how many degrees would it be? Oops, I didn't actually. Wait, I need to plot it. 1, 3. A is 2, 2. And T prime is 1, 0. Okay, so let's see when we go clockwise how many degrees that will be. Hopefully you already know. But if I go clockwise and I want to put CAT on top of C prime, A prime, T prime, going clockwise is just one rotation of 90 degrees. So that would mean negative 90 degrees because we went clockwise. So we could also call this negative 90 degrees. Okay, so these are the rules for rotations that you want to know. And of course, if it's 360 degrees, then it takes you right back to where you started. But you want to know the general rules for these, because you're not going to be allowed tracing paper on your quiz or test.